Today we're going to talk about a paper on mental models of an AI system. So let's imagine we're interacting with Claude. It's similar to ChatGPT if you haven't heard of it. And I want to learn about quantum computing or get an explanation of quantum computing. If I'm a novice at using AI, I might just say, what is quantum computing? And I get an answer that is reasonable. Um, but it might be that it's missing out on key concepts. So if I'm an expert at AI, meaning I know how to use prompts well, I might say, I want to understand the key concepts, explain as if you were explaining to a high school student. These large language models are very good at interpreting, imagine you are an executive in sales, or imagine you are an inventor and you can give it these roles to play. So an AI expert is going to do something like that and get an explanation that might be more tailored to their needs. So this study is about what does it mean to be AI literate or to have better expertise with an AI agent than other people? And can we measure that? It probably takes practice. There might be some education. Maybe you have to understand the agent, knowledge about a particular agent, and then people are going to differ. Um, let's imagine that there's time and complexity over time and history. So the first agent that people interacted with strongly was Eliza. It was a chat bot and it was very engaging for people. Very simple though. You would just type in things like, it would say, what is bothering you? It was trying to be a therapist, and you could say, I'm having trouble sleeping. And it would say, why are you having trouble sleeping? And then it would just sort of echo back to you. But people really engaged. The Clippy was an agent in the 90s that people did engage with sometimes. They also didn't like it typically. Now we've got Siri, Alexa, this sort of thing, and then we get Claude, ChatGPT, Copilot, the others. So they're rising in complexity, which means we have to have more knowledge to understand how to work with them. So how are you going to measure expertise with an agent? So when you look at expertise generally, how do you measure expertise? There are two common components. One is prior experience. I am an expert at evaluating art forgeries, or I am an expert at doing whatever, right? You have the experience. And then there's performance in the real world. So I have identified, 25 art forgeries, and that's better than the next person who has only identified 10. So we have performance and prior experience. And we try to incorporate these principles sorry, into this AIX model, the user's AI expertise, the AI expertise, or AIX model. And let's walk through this. So the first bit is the AI expertise over in this block here in this color. What do you know about the agent? And what experience do you have with this agent? And you notice the difference here, theoretical and practical knowledge. So theoretical knowledge, so this was not, what do you know about the agent? This is like, what do you know about AI capability in general? And then prior experience with this agent, and then prior experience with other AI agents, which might help you relate, right? And then those are going to add up to all be your AI expertise, AIX. And then we've got your context. Why are you even using this agent? What are your goals? What is the strategy you're using? And what is your knowledge of this task? Are you an expert at this task or not? So those are then going to influence both your AI expertise from before and your task and your context are going to influence your user interactions with the agent here. And that's going to affect your human agent task performance. And then there's going to be a feedback loop that's going to go back and affect that experience with this agent. So you might say, well, that's a fine model theoretically, but how does this model really help me? Well, in the paper that goes with this presentation, we envision three different agents: a Netflix style movie recommending agent, a Kiwi bot that plays a game called Kiwi, and an EcoPat that's like a smart home that tries to help you do things to your home that are sustainable and help you save energy and save the planet. And that's an agent that we analyze each of these three agents in terms of that model to see if the model can do work for us and help us out. Turns out it can. In this presentation, I'm just going to talk about the Kiwi bot. So in the Kiwi bot, we'll first look at that part. So this Kiwi is a game. It's spelled Keywe, Kiwi, and in which um, it's a two-player game, a little bit like Overcooked, if you've seen that one, except you're in a post office and you are two Kiwi birds. So each player is a Kiwi bird, and you have to manage this post office and pick up packages and letters and get them shipped off to the right place. And in a study we've done, we told participants that you get to play this game with a KiwiBot agent. And KiwiBot agent was really a human in the background using Wizard of Oz style technology. And it was actually two humans in the background because it took two humans, one to play and move the agent around, move the Kiwi bird around the game as if it were obeying commands of the human player. And the other human on the behind the Kiwi bot was talking. And they would talk following a script. So if the human said to the Kiwi bird, "Can you go pick up that label?" it would say, "I will." And it would say a certain number of responses. So it was a sort of mock agent. And when people played this, people did this study, it'd be like, "Welcome to this study. You're going to be playing Kiwi. Here is a 5-minute intro to KiwiBot." And we explained that you can just talk to it. It can explain the game. It can play the game, do whatever you want. And this agent was built to only do things when asked. You could delegate to it. You can ask it to do things, but it would never take initiative and do things on its own. And so we had the theoretical knowledge of the agent. That was the first block. The next block was, well, uh, you had experience. You played several levels of the game, and maybe people had other experience with other agents that maybe did not understand them because they had a thick accent, or they said, "Well, this agent's not as proactive as another game I play," that sort of thing. And now let's look at the task. And your goals in the game are, to perform well in the game, basically. Maybe just to figure it out. And your strategy is to try out KiwiBot some, maybe learn the game, maybe use KiwiBot to learn the game. What are the rules, KiwiBot? What do we need to do next? That sort of thing. And we would, as participants did this, we saw them use different strategies. All the participants had a game tutorial about how does this game work, and general gaming knowledge and experience playing the game. These were the types of things. So then those are all adding up to the hat performance. And the implication for designer research is that all of this actually matters when you design agents. So how do we measure all this? We had them play, and then we did some surveys and interviews. So the survey might say on a scale of 1 to 10, how reliable was KiwiBot when you asked it to do things? Then we actually observed behaviors in the gameplay, and we counted up how many times people delegated tasks to KiwiBot. And of course, also we have the game score that KiwiBot and the player did together. So it's sort of a team score. And these are different kinds of dependent variable and metrics that we used. Here's how these different variables map onto what we've talked about. So we're going to survey their AI capabilities, and we have an interview about that. That's a little less structured. We're going to observe their behaviors with the goals and with the strategies, interview them a bit, survey, and then we can observe their performance with the score. So all of these factors matter for agents, and this is our approach to doing one study. We're going to have our results published or submitted soon for publication. We're about to finish a paper, and I thought you might be interested to see this in case it helps you think about human-agent interaction. All right, thank you.